All right, so I received this NSP-3 from Apex today. It's not guaranteed to function, and it came with this lovely note on it. Bad power control, which I believe, because when we power the unit up, I've got 4.5 volts or thereabouts fed into the battery container because of all of the batteries that came with it. Although the Century paperwork in the unit says are all come charged to have none voltage. So when we power it up, we get a kind of pulsating whine from the transformer. So I assume we've got something that's shorting, or we're not reaching full voltage, or something is short circuiting and crowbaring it. So I'll let you hear that here. So we'll pop the cover and take a look and see what's inside this thing next. Okay, so inside the cover we get the main power unit here, which consists of a couple of transistors, these guys here, and a big transformer. This is a multi-tap transformer, as well as some other biasing components. And then we got a neat method of it getting connected. You can see it's got these sockets on this side, little rectangular sockets, right, and a single almost RF type connector here, and those mate up to the RF type connector goes there, and you've got blade connector here, blade connector here. A neat way of making sure you can't do anything interesting with the transformer when it's removed in the field. So next thing we're gonna do is try to bypass that quote safety arrangement and see if we can get this thing to power up outside of its chassis and see if the behavior is the same. A second here to cover the what you get for a schematic inside the manual. So essentially here we've got our common point comes over. This is our battery arrangement. I should say 4.5 volts. Not sure why they're showing the switch here, as I think these are supposed to be the contact points where the battery goes into the unit. And clearly the switch to turn it on and off is not there. It's up in this unit someplace, where actually it's in the chassis somewhere. So they're kind of mucking with the schematic a little bit already. But here we can see our 2 transistors in the schematic, our biasing circuit, a couple of capacitors here, and then our multi-tap transformer to provide a boost. As these guys basically flip-flop is my bet, providing what amounts to a sort of AC waveform that goes through the transformer and then gets jacked up to a higher voltage here. You can see they actually label it. I believe that's supposed to say 38 kilovolts, which would be rather an enormous amount of voltage, and kind of sort of scares me as far as having this thing apart and fiddling with it. But here we've got our diode bridge. This is essentially a doubler circuit for anybody who's seen it before. Well, I should say a multiplier circuit for anybody who's seen one before. So essentially the AC waveform comes through here. As it passes in one direction, we charge the other capacitor. When it goes and flip-flops in the other direction, these diodes stop conducting, the other diodes start conducting, and essentially we stack a new capacitor into the arrangement, and each time we do that, we increase the AC voltage that is seen across these 2 terminals. So I did the same thing when I was trying to build a power supply for a homebrewed grounded grid amplifier, which I still haven't finished. So that's how that operates. You can look that up. It's called a diode multiplier or a DC multiplier circuit. And then that eventually gets fed to the tube with these biasing capacitors and resistors. Okay, let's tear the power unit apart a little further. All right, so we've got this effectively bypassed now. The connection's going the right place in decent spark gap distances in case I screwed something up. We'll give it a go. All right, and as expected, we still have the ticking. The ticking is quite obviously coming from the tube itself and not from the power board. So I think that's not necessarily good news. So that could be something with the tube itself, which would obviously be bad, or some of the other circuitry. So the next thing I'm going to do is try removing this connection here and see if that makes any difference. Alright, so here's some video of the DC power in to the NSP-3 when it's doing the ticky ticky ticky. And the tick corresponds to that large transient event, which I'm guessing is something shorting out.